So with that, our next speaker is from our very close collaboration in terms of trusted CI. And so their mission in the world is to make AI more secure, or excuse me, trusted CI. I was part of trusted AI to make cyber infrastructure more secure. And I will let um, Drew and talk a little bit about how scientific security considerations in the age of AI.
Thanks, Chuck. Can you hear me okay?
I can, thank you.
Perfect. Yeah, I just want to say thank you again to our CI Compass colleagues for including us in this lovely multi-day workshop. It's been really nice personally getting past just the hype of AI and seeing a lot of nice concrete examples and critical thinking. Um, Bit of introduction. I'm Drew Paine. I'm a user experience research lead in the scientific data division at Lawrence Berkeley National Laboratory. And among the portfolio of projects that I work on, one of them is Trusted CI. And I'm joined by my colleague Dhwanit Pandya from IU. He's wrapping up a master's in cybersecurity with a focus on AI use. So I invited him to join me and provide us with some of his burgeoning expertise. And we're members of a newly formed project within Trusted CI called the Secure Use of AI team that I'll get into in a minute. Um, for those who may or may not be aware, Trusted CI is the NSF Cybersecurity Center of Excellence, and our mission is really to support the broad NSF-funded cyber infrastructure community, especially cyber infrastructure operators, with securing research infrastructure and research programs. We have a well-known framework and cohort process for helping different NSF-funded major facilities and mid-scale facilities ensure that they're able to effectively support the incredibly varied range of research happening under the umbrella of the NSF. And, we'll have a blog post soon, but with the shifts in the last year, our focus is expanding a little bit to both think about research security in partnership with the Secure Center, and then also think about AI in the scientific process and the security of that. And hopefully some of that will happen in collaboration with our friends here at CI Compass. But for now, I'm going to talk a little bit about some of the introductory or background work that our team's been doing and what we're thinking, and then I'll let Dhwanit wrap up by getting into some examples and just considerations we've had. So as we've seen the last few, today, yesterday, and just in general, the research landscape is evolving rapidly as AI enters infrastructure, people's practices, and also policies. It was really nice hearing, I believe it was Raj earlier from Hui talking about how they've had to figure out what kind of procurement practices and all that around ChatGPT and other things. We've seen a lot of discussion in the last day about shifting scientific software development practices. Some interesting work that we've been looking at. One is just, that validation issue that's come up. There's some fun work from L. O'Brien at University of Michigan, funded by the Sloan Foundation, surveying and interviewing scientists about their efforts using these tools and their thoughts and concerns. And then we just seen some also interesting work on, just adoption of these tools. We're also hearing a lot about goals of having agentic infrastructure for autonomous research activities, cyber physical systems. How do you automate laboratories and those different processes, which is fascinating, but also probably pretty scary. And then we're also seeing federal initiatives, guidance, and policies that are changing quickly. NSF has put out AI strategic pillars. I don't know. As somebody in DOE, I hear a lot about Genesis mission, which was brought up yesterday. I'm just seeing the different ways the federal landscape and support for AI is evolving is fascinating. At the same time, though, we're seeing that this brings a rapidly evolving threat landscape. As AI enters these research environments, that security practices and policies aren't necessarily keeping up. Security practices are probably a lagging aspect of research environments to begin with in many respects, depending on the funding source and the type of research that open science movement is not always in line with some particular forms of security consideration. Just the other day, we're seeing a lot of concerns around data pilfering from things like ChatGPT. We've also seen research from Google DeepMind and other organizations about the risks with frontier AI models and just can they actually accelerate the ability of bad actors to undertake threat actions in a very automated way? And so, what we as a team that's just forming started thinking about a bit is, there's these fundamental challenges for research cyber infrastructure organizations as behaviors change with combinations of AI systems, cyber infrastructure, and scientific methods being adopted. And so, we think that's going to require adjusting and enhancing security practice for research, and that's a goal that we're going to explore. Before I talk briefly about our project, I'll also just mention industry and government are also advancing a lot of different AI security frameworks. Just in the last 5 years, we've seen things from MITRE, NIST, Google, Cisco, and so on, and figuring out what elements of these are relevant to cyber infrastructure operators and their needs that are not necessarily the same as commercial environments or, say, healthcare environments is a thing of interest and that we hope to undertake as Trusted CI in collaboration with the broader NSF research cyber infrastructure community. So we have launched a project as of last week, effectively, to investigate what do we need to do as a cybersecurity center of excellence to support you all as a community at the intersection of AI and cybersecurity. We framed our initial focuses around secure use AI, particularly in research processes and systems, and some things we've been thinking about. And I think it's on the right track. We're having heard talks today and yesterday on resource procurement, software development in particular, and how can we develop effective guidance or to support folks, and then thinking about that agentic AI and AI driven research infrastructure and cyber physical systems. There's the talks and panel yesterday on data and AI was great, and one of the things that's kind of a secondary focus is thinking about the security of data for AI, whether it's for use in training and all that. And that's one of the things we're exploring. And then also the security processes using AI. How do you actually use AI to, monitor your infrastructure and all that? So currently we're doing a lot of work reviewing industry efforts, best practices, so that we can have some effective conversations and engagement with stakeholders. But I will definitely underscore, we want to hear from the community. What's challenging to you? What are you thinking about? What do you think you're missing? And so please let us know and reach out, via our website or, I'm around today and tomorrow as well. And I think I'm on the CI Compass Slack as well. And with that, I want to hand things over to my colleague Dhwanit, who can talk about a little bit of a preliminary work we've done looking at some literature review and all that, and investigating the landscape and implications for cyber infrastructure organizations just at a kind of, I'll say, 30,000-foot view, but Dhwanit can correct me if I'm wrong.
Sure, thank you so much, Drew. So I just want to start by grounding this discussion in three themes of reality. First is the governmental context. This is where the expectations are set, the policies, standards, and governance frameworks that define what responsible AI even means. It establishes the baseline for how AI should be built and used in research environments. Next is the industry framework, industry efforts. This is where those expectations turns into systems. Industry is building secure, scalable AI platforms while responding to a rapidly evolving threat landscape. And this theme is all about efforts to make AI more powerful and safe. And finally, we have the research adoption challenges. This is the operational reality. Research labs and facilities face day-to-day constraints, trade-offs, and practical risks. And this is where the policy and tooling meet real workflows, limited resources, and real adversaries. So the gap between these teams is where most failures happen, and it is exactly where research infrastructure feels the most pain. So everything I'll show next lives in that gap between intention and reality. Drew, can you switch to the next slide, please? Yeah. So this theme is about the policies around AI. We have already discussed the NSF AI strategy plan, which is aligned with the OMB M2521 guidance. which signals that AI is no longer experimental in federal ecosystems. Facilities and research environments will increasingly be expected to account for these AI in their cybersecurity and risk programs. Drew already walked you through the um, four strategic pillars of the NSF AI strategic plan, that is governance, mission-driven AI use case, having an AI-ready data and infrastructure, and accelerating responsible innovation along with having an AI-ready workforce. In fact, this CI Compass event has revolved around these pillars, isn't it? So the government is positioning AI as a workforce multiplier, something that improves efficiency, decision quality, and mission impact. But that powers comes with some sort of expectations, and those expectations are having a risk management framework for AI, not any adoption for AI. In practice, federal adoption is really facing similar challenges. For example, handling sensitive data, establishing accountability, and justifying the upfront cost that AI brings with it. So the response has been a push towards trustworthy AI systems and having a phased adoption along with mechanisms like software bill of materials to improve transparency. One of the concrete examples I would like to discuss is about the procurement. So the OMB M2522 guides how the government treats AI systems like critical infrastructure. Federal agencies are expected to define requirements, evaluate vendors, guard against vendor lock-in, and set benchmarks and even periodically reevaluate the systems that they have. So this is basically a mindset shift. AI is no longer treated as a software. It is a regulated capability with a lifecycle risk. So what's important for research infrastructure is these expectations don't stop at the federal agencies. They do cascade. Research labs and facilities inherit these model often without the same resources to implement it. So Dhruv, can you move on to the next slide, please? Yeah, so this slide basically captures the full arc of what's happening in the real world. So first, the current threat landscape. We are seeing that simple role playing, such as assuming the role of a researcher and using a cooperative language, is one of the most effective ways to bypass LLM's safeguards, and that's social engineering for a machine level. So I'll walk you through an example in the very next slide where we'll discuss the prompt injection attack, and I'll walk you through a real case how it works. But we also have seen the supply chain attacks, for example, slop spotting, where LLM models do hallucinate package names and attackers register them on official websites. And according to one of the threat intel reports by Anthropic, AI can now autonomously execute up to 80 to 90% of an attack chain. And that is no longer just theoretical. Secondly, moving on to the efforts taken by the industry is responding with a great effort. NVIDIA and Microsoft have recently collaborated to form a real-time AI defense with a great speedups and high detection accuracy. We are also seeing some sort of structured risk frameworks emerging to bring discipline into the AI security. And finally, we have solutions for research environments. The path forward has to be a bit more practical and pragmatic. So digital twins is a proven solution for industrial control systems, and I believe it can also help us test AI behavior safely in realistic environments. And as far as regulated environments such as healthcare is concerned, experts increasingly lean towards running AI locally to preserve privacy and transparency and even more control over the AI model that you are currently using. So here the takeaway is simple. The threats are there, defenses are emerging, and the research infrastructure sits right in the middle of this. Next slide, please. Yeah, so I want to discuss about prompt injection. So there are two types of prompt injection, that is direct and indirect. So that on the left is direct prompt injection. Here the attackers directly talk with the model. They do use tricks like playing as assuming a role as a researcher, overriding or manipulating the system prompt. This is the classic ignore previous instruction style attack, and it is visible, and in controlled environments it can often be detected and filtered. For example, if you look at the example on the left side at the bottom,
Dhwanit might have frozen.
I think the might has been answered. I think he has frozen.
Yes.
Um,
So yeah, as Dhwanit was saying, direct prompt injection example here, put together, thinking about how a PI is in a genomics facility is using just a generic chatbot like ChatGPT or all that, and asking it, providing it with access to some of those labs, resource materials, and all that, and trying to use it as a research assistant, and treating it as a super user researcher. Donnie's
He's
back.
back. Yep.
I was
Sorry,
just
just
starting to
got
talk
my
about. Sorry.
internet. Yeah.
Please,
So
please.
I was talking about the example, right? So we see that the AI models get tricked and it reveals all the proprietary or confidential data set along with the owner names, which is a big risk issue, right? And moving on to the indirect prompt injection attack, this is where things get a bit more dangerous. For example, here the attacker never talks to the model directly. They poison an external source. For example, it can be a web page or a document or a data set. The AI system later summarizes or retrieves that content, unknowingly executes the attacker's instructions. Here, the user is innocent, but they ask to summarize the particular page, and the model becomes the attack vector here. For example, if you see the example that is listed at the rightmost bottom, you see that if I give a prompt to my chatbot, like give me the top 10 best purchasing option as far as tools are concerned, and if it happens to visit this particular site, it goes through the malicious prompt that is listed on this website, and it gives me that this particular tool is one of the most best purchasing option, which in real case it might not be. So this is how indirect prompt injection works. So in research infrastructure, this is especially risky. The result from one of the polls from yesterday indicated that summarization is one of the top use case of AI by the audience. Additionally, we ingest papers, logs, datasets, and web content and share documents all the time, right? So any one of those could become a delivery mechanism. So the key shift is with indirect prompt injection, trust moves from user to the data pipeline. And most research systems were never designed with that threat model in the mind, right? Can you move on to the next slide, please? Yeah, so this slide basically captures the tension at the heart of AI in research. So this pyramid shows how AI research grows and follows a bottom-up approach. Widespread adoption in reality exposes challenges, and those challenges become a catalyst for meaningful innovation. At the bottom is the adoption. AI is spreading differently from any other prior technology that we had. The usual life cycle is invention, then innovation, diffusion, and in this case, it has totally flipped for AI. Consumers, including researchers, adopted AI first, long before institutions and policy frameworks caught up. That's why we now see AI embedded in everyday workflows without formal governance around it. On the right, we have challenges that naturally follow. Researchers report major productivity gains, especially in writing and analysis, but they also encounter persistent issues, for example, hallucinations, data privacy risk, and ethical concerns. So we have real value paired with a real risk, and at its core, this has become a question of understanding trade-offs and defining risk tolerance. And at the top, we have innovation. Innovations like Curate GPT shows what's actually possible. LLM-based multi-agent frameworks designed to make research data fair, trustworthy, and sustainable. These approaches allow custom use cases that fit the data, domain, and the constraints of research environments. So here, the opportunity is to identify the best practices and shape that innovation so that the innovation aligns with how research environments actually work rather than forcing research to adapt to tools that were actually built for consumers or enterprises. Over to you, Drew.
Thanks, Tony. And I'll just briefly end by saying thank you for the opportunity to speak again. And we're, as I mentioned, really just getting started with our work on this as a team in Trusted CI. And so we're very open to community input and feedback, and would love to hear from you either via our website's contact form or email to info@trustedci.org or myself, and I'll make sure these slides are shared so you have that. Chuck, I know we have a couple of minutes if anyone has
Yeah,
questions.
I was just going to say we have maybe 2 minutes, 3 minutes that we could have questions from the audience. So if there, I have a question or two. So I think one of the really interesting, sort of notions from cybersecurity is this idea of controls, right?
Hmm.
And I was kind of curious as to both through your review or through sort of experience, I can see, controls in sort of a multifaceted way that AI could help us to do controls, but then AI needs a unique set of controls in and of itself, right? Um, could you guys maybe comment or talk a little bit about, how this sort of readily identifiable governance system that cybersecurity is as sort of adopted might be, extended to AI.
Sure. I think from my time on the Trusted CI framework team, where we've been looking at controls and especially NSF's research infrastructure guide, which has what I think they're kind of tentatively framing as like 14 controls. It is a question very much on the broader team's mind of what elements move beyond um, just the human documentation element and what is programmatic and automated. You know, that is of interest to me. I don't have a direct, clear answer, but I want to see if Dhwanit does, as somebody who's spent time exploring AI use and all that. I don't know if he's explored if controls have been part of his work though.
Yeah, we do have controls like we have the NIST AI framework, but we haven't had proper frameworks that keep evolving. So AI is an evolving field, right? So if we have controls set, or if we have any publications from NIST on a particular date, by the time we have implemented it, it has already become obsolete for many use cases. For example, we didn't have any term known as agentic AI, which was included in the NSF in the NIST AI RMF framework. So it is difficult to have controls for AI. So I believe is we need to keep ourselves updated with all the recent frameworks that we have and use those controls that better fit our research environments and something that we can be consistent with. That would, I believe, fetch us the most optimal results as far as AI is concerned.
All right, thank you very much. Thank you for the answer. Thank you for this wonderful presentation. And I hope that the audience would join me in thanking our colleagues for this presentation.